Alright class, so today we're going to cover section 7.3, which is all about simplifying radicals. The first thing I want us to do is talk about how to simplify radical expressions and non-perfect square roots. Okay, so let's take for example the square root of 20. What we want to do is we want to factor the radicand and find the squares. We can do that by making a factor tree. So 20 is 4 times 5, which is 2 times 2. So I can rewrite 20 as the square root of 2 squared times 5. So I'm going to go ahead and put that under the radical. Well, we can pull this apart. This would give me the square root of 2 squared times the square root of 5. And we're going to talk more about the product property, so multiplying radicals, in the next couple slides. But first I want to focus on simplifying. So if I have the square root of 2 squared, it's important to remember that square roots cancel squares. So that would leave me with 2 times the square root of 5. Okay, let's practice this other one. I have 15, which factors into a 3 and a 5. Okay, there are no squares, so no duplicates like I had over here in 20. So the square root of 15 is fully factored. Next, I have the cube root of 16. 16 is 4 times 4, which is 2 times 2 times 2 times 2. Is there a cube in here? Well, there is. I have 2 cubed times 2. So because I was looking at the cube root, I want to collect cubes. When I was looking for the square root, I collected squares. So I have the cube root of 2 cubed times 2. I can pull this apart to the square root of 2 cubed times the square root of 2. That leaves me with 2 square root of 2. Next, I have the square root of 24. So let's go ahead and make a factor tree for 24. 24 is 2 times 12, which is 4 times 3, which is 2 times 2. So are there any squares here? Yes, yes there is. I have 2 2's, a 2 and a 3. So I can pull this apart. This is going to give me the square root of 2 squared times 2 times 3. Remember, square roots canceled squares. So I'm left with 2 square root of 2 times 3. I'm going to go ahead and write that as 2 square root of 6, because 2 times 3 is 6. Next, I have the square root of 108. 108, that's going to factor into a 2 and a 54, which factors into a 2 and a 27, which factors into a 9 and a 3, which factors into 2 3's. Okay, so do I have some squares? I do. I have 2 2's, I have 2 3's, and I've got 1 3 left over. So I can rewrite the square root of 108 as 2 squared times 3 squared times 3, all under the radical. That's going to leave me with 2, because square roots cancel squares, 2 times 3, because square roots cancel squares, times the square root of 3. So I am left with 6 square root of 3. And we're going to get a lot more practice working with these going on. It's going to be really important for our next section. Let's do a few more examples. So this first example I have is 16m cubed. So let's go ahead and factor 16m cubed to see if there are any perfect squares that come out. Remember, we're taking the square root in this case for number 1. So I have 16m cubed. That gives me a 16 and an n cubed. Remember, you have to factor your variable part as well. I'm going to have m. 16 factors into a 4 and a 4, which factors into a 2 and a 2, which factors into a 2 and a 2. So since I'm finding the square root, I want to collect the squares. I have 2 2's, 2 more 2's, and 2 m's. All I have left over is 1 m. So I'm going to rewrite the square root of 16m cubed as the square root of 2 squared times 2 squared times m squared times m. Remember, I can pull these factors apart. Oops. So I would have the square root of 2 squared times the square root of 2 squared times the square root of m squared times m. And remember that square roots kind of cancel squares, right? Remember the square root, I was taking the square root of 2, that's the same as 2 to the 1/2. So if I was taking the square root of 2 squared, that's the same as 2 squared to the 1/2. I multiply those together and get 2 to the first. So this is kind of where we came from if we think back to the beginning of this chapter. So I'm left with 2 times m square root of m. So I have 4m square root of m as my final fully simplified answer. All right, so we've completed the first problem. Why don't I go ahead and make us some more room, and we'll work on problem number 2. Okay, so here I have 200 k to the 7th q to the 8th, and I'm taking the square root, right? There's an imaginary 2 right there. So the first thing I want to do is factor this, okay? So I have 200 k to the 7th q to the 8th. So that means I have 7 k's. That's 6. 7. I have 8 q's. 1, 2, 3, 4, 5, 6, 7, 8. And then 200 factors into a 2 and a 100, which factors into a 10 and a 10, a 2 and a 5, a 2 and a 5. And since I'm looking for the square root, I need to collect all of the squares. So let's circle those. Well, I'm going to start with my constant first, not my variable. So I've got 2 2's, I've got 2 5's, and then I have a 2 left over. Then here I have 2 k's, 2 k's, 2 k's, and 1 k left over. And here I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 4 sets of q squared. So I can rewrite our original problem as this. I'm going to do the square root of 2 squared times 5 squared times 2 times k squared times k squared times k squared times k times q squared times q squared times q squared times q squared. Remembering that square roots undo squares. So this 2 is going to be, this square root is going to be canceled, and it's just going to be a 2 on the outside of our radical. This 5 is going to be canceled, so it's going to be a 5 on this outside of our radical. This 2 is all by itself, so it's going to stay under our radical. This k is going to come outside the radical, as is this one, as is this one. But this k was all by itself, so it stays under the radical. And then I'm going to have 1, 2, 3, 4 q's coming outside of the radical. So I'm left with 2 times 5, which is 10, k cubed, q to the 4th, square root of 2k. Final answer. Okay, we think we're ready to conquer one more. Let's take a look at example number 3. Now it's different. Now I'm finding the cube root. Okay, I'm finding the cube root of negative 8x to the 4th, y to the 5th. So instead of collecting groups of 2 like we did in examples 1 and 2, now we're collecting groupings of 3. So I have, what do I have? I have negative 8x to the 4th, y to the 5th. Okay? Now, negative 8 is going to factor into negative 2 times negative 2 times negative 2, right? We know the cube root of negative 8 is 2. I'm going to have 4 x's and 5 y's. and I need to collect my groups of 3. So I've got 3 -2s, 3 3s, and 3 y's. So I'm going to rewrite this original problem over here as the square root of -2 cubed, x cubed times x, y cubed times y squared. Okay, my cube root is going to cancel my cubes. So I have -2 x. I'm going to have under my radical an x because it's all by itself. This cube root cancels out this cube, so I've got a y and a y squared. So I'm left with -2xy x y squared. All right, for these last 2 examples, we're going to have to do something a little bit different than we had before. So let's take a look. I have 9 square root of 5, 6. Now, remember, if I'm taking the 9th root, that's the same as raising something to the 1/9 power. So if I have 5 to the 6th to the 1/9, I multiply those together, I get 5 6/9. That gives me, how can I simplify 6/9? I definitely want to simplify that fraction. So that's going to give me 5 2/3. Okay, let's change this back to a radical. That's going to give me the cube root of 5 squared. So I'm left with the cube root of 25. I'm not going to erase this example because I want you guys to keep it in mind when we work on example 2. So here I have this 4th root of p squared. So that's p squared to the 1/4. I multiply my exponents. So I have p to the 2/4, which equals p to the 1/2, which is really just the square root of p.